Welcome to the solutions video for Math 30-2, Homework Assignment 5.01, number 1. We're dealing with 12-y.4. So, a grocery store manager took inventory of all the fruit to decide what needed to be donated. Of the 8 pieces of fruit deemed overripe, 6 were mangoes. If the manager randomly selected 5 of the overripe pieces for the first donation package, what is the probability that all of them are mangoes? We want to write that answer as a decimal rounded to 4 places. Well, we have to do this in steps. So the number of outcomes we're including are where all 5 of the overripe fruit selected are mangoes, and that's only 6 out of the 8. So, okay. I don't know why it is still responding like that. Okay. Might be a mouse square placement issue. We'll take a look. All right, so of the 5 fruits that are chosen, okay, I need to do the reload thing. Here we go. Of the 5 selected fruit, or that's not what I'm choosing. So what are the odds of choosing 5 mangoes from the 6? Divided by all possibilities, how many ways are there to choose 5 of the 8? This is the way we solve the problem. So 5 of the 6 fruit chosen are mangoes versus 5 of the 8 availables. So this is how many ways there are to choose 5 fruit. In the denominator, and the numerator is the number of ways that those are all mangoes. So we have 6C5, and that is divided by 8C5. To 4 decimal places, that is 0.1071. Question 2. Juliet and her best friend wanted to paint their apartment. In their storage closet, they found 9 pans of paint. Juliet remembers that 7 are yellow, but none of the cans have labels. If Juliet randomly opens 6 cans, what's the probability that all of them contain yellow paint? It is a very similar idea. Sorry, wrong tab. So in this case, what are the odds that we pick of the 7 yellow? We choose 6 of them when we are choosing 6 out of the 9 total cans. So 7C6, we have 7 ways to do the top option, and that's 9C6 ways to choose the bottom option. So 7 out of 64, or 7 out of 84 is 1 in 12. So that's 0.08 and then 3 repeating. So to 4 decimal places, that's 0.833. Now we've got 19 goodie bags, 12 in the cafeteria. If 16 were randomly chosen during the first period, what is the probability that exactly 10 of the goodie bags were hidden in the cafeteria? So if we find 16 of them and exactly 10 from came from the cafeteria, then what we have is a 2-step problem. So we find 10 of the 12 in the cafeteria, and we found 16 total, so we need an and there's 12 are in the cafeteria. That means of the other 7, we found 6. And all possibilities mean we found 16 goodie bags of the 19 that were hidden. So once again, the denominator is easier to calculate than the numerator. So we have a 12C10. So we have 66. 7C6 is just 7. And 19C16 is 969. So we're looking at 462 out of 969, or 0.4768 when we round it to 4 decimal places. So 0.4768. Now, Jeremy was feeling particularly adventurous at the hair salon one day and decided to dye his hair. With 15 colors to choose from, 12 were shades of blonde. If he randomly selects 12, what is the probability that exactly 10 are blonde? So it's the very same setup that we had in the last one. I'm just going to move this tab out of the way because it keeps getting distracting. So there's 15 to choose from, 12 are blonde. Okay, and he's choosing 12 total. So our denominator is 15C12. Now our numerator, he's choosing exactly 10 blonde. So that's, of those 12, he chooses 10. But he's not just giving 10 options, he's giving 12 options. So the other two that he is choosing must come from the 15 minus 12, or 3 shades that are not blonde. So 15C10 we know is 66. We've seen that before. 3C2 is 3. And 15C12 is 455. 66 times 3 over 455 is 0.43516, or 0.4352 to 4 decimal places. Oh, didn't want to do that. 0.4352. So, Amy conducted an experiment to see which of her friends had the best sense of smell. 8 scratch and sniff stickers, 4 of which were lemon. If you randomly choose 5, what's the probability that the first 2 smelled like lemons? So, what's the probability that the first 2 smelled like lemons? That means of these 4, we're choosing 2. And it's specifically the first 2, which changes the problem. That means only the first 2 matter. So of her 8 Snickers, just the first 2 have to be lemon, and that's 4 to pick from. The other 3 can smell like anything. They can smell like lemon, they can smell like not lemon. That's not an issue. So we could do case by case with everything else, but really this is the only math that we need to do. So we have 4 choose 2 divided by 8 choose 2. That's 0.2143. Okay, and they have a different answer here. Oh, it's because I missed the word just. It was just the first 2. So then the other 3 should not have been. So it should have been that, and of the remaining 4 Snickers, we choose 3. And of the remaining 6 stickers, we choose 3. So that's 4 divided by 6, choose 3. That is 0.2. So if we multiply that by our previous answer, that gives the 0.042 and 9 that they have. So I missed the word just because I wasn't reading carefully. And now we get exactly the number they have. So that was the issue. So, question number 5. Violet brought 9 bagels to school, 6 of which are blueberry. If Violet randomly gives 4 bagels to teachers, what's the probability that exactly 2 of the chosen bagels are blueberry? So, first of all, she's giving away 4 of the 9. So that's our denominator. So of the 9, she's choosing 4. And in our numerator, so we are doing exactly 2. So 2 of the 6 are blueberry. So we're choosing 6 of these 2, and we're choosing 2 of the other 3. So 6C2 is 15 times 3 divided by 9, C4. It's 0.3571. Okay. Now there are 9 students performing at a talent show, 3 of whom will perform magic tricks. If 4 are chosen during the first section, what's the probability that just the first 2 of the chosen students will perform magic tricks? So, what's the probability of choosing 2 of these 3? So here we go again. This time I'm not going to miss the word just. So we are choosing 4 of the 9. But first, it's the first 2 that matter. So we are choosing 2 of those 9. And they are going to include 2 of the 3 that do magic tricks. And when we choose our next 2 acts, we'll have 7 acts to choose from. And these 2 will be from the 6 that are not performing magic tricks. So we need to set this up to not make the mistake I made before. So that's 3 over 9, choose 2, which is 1/12, times, and then we have 6 choose 2 over, choose 2, divided by 7, choose 2. So when we multiply all this out, we get 0.0595. So 0.0595. Now, question number 8. During the secondary school's Welcome Back Pep Rally, 11 different clubs were introduced, including 3 sports clubs. If 4 of the clubs were randomly selected in order to make a human tunnel of students, what's the probability that just the first 2 are sports? So again, it's just and it's the first 2. So we have 11 clubs, 3 of them are sports. So for the first 2, we choose 2 of the 3 sports clubs and 2 of the 11 clubs total. And then if we're doing 4 in total, so we are choosing 2 more from the 8 clubs that are not sports when we're choosing from the 9 remaining clubs. So 3C2 divided by 11C2, and that's about 0.0545454 repeating. We're multiplying that by 8C2 and dividing by 9C2. So multiply all this together, and we get about 0.042424, and that 42 repeats. That's a terrible 4. So 0.0424. Now, number 9. Henry mixed together different kinds of nuts in a sack. There were 12 nuts in the bowl, 6 of which were pistachios. If he chooses for the nuts to eat in a specific order, what is the probability that just the first 2 of the nuts are pistachios? So, again, we're choosing 4 out of 12 and 6 are pistachios. So it's the same setup we have here. So first we're choosing 6 choose 2 and 6 choose 2. Or sorry, out of all possible options. So that's 6 choose 2 out of 12 choose 2. I don't know why I was saying 12 but writing 6 again. And then the next 2 are not pistachios because it's just the first 2. That word just, that stung me before. And there are 10 left to pick from. So 6 choose 2 is 15. Might as well write all of these out here. 12 choose 2 is 66. 10 choose 2 is 45. So that's the same as 5 over 66, since 15 over 45 is 1 over 3, and then 15 divided by 3. So 5 over 66 produces 0.0757575, and that's repeating, or 0.0758. 0.0758. And now number 10, to wrap up the first assignment. Stella got a summer job at a movie theater cleaning aisles after each film. The Sunday 62 movies are scheduled to show, 43 of which feature an animal as the one main protagonist. That's a strange schedule for a theater. Is Stella randomly assigned to clean up after 59 movies? What's the probability that exactly 41 would feature an animal as the main character? So, again, we have to pick from 41 out of the 43 satisfy the conditions of having an animal for a main character. And then of the 62 movies, she's cleaning up after 59. So we're choosing these, and these are all possible options. So, yes, she's cleaning up after 59 of the movies. That is a very different workload compared to my theater days. Of course, my theater only had 4 screens. So I'm getting a 0.02387625559. But this is, oh no, she has to do 41 of these, and she's got 43 out of 62 movies. So 19 of the movies then do not feature animals. And she has to choose, or they're chosen 18 of those. So we have to multiply this by another 19. That's why it's only a 2% chance. It really should be much higher. It's 0.4536 once we include that 19 out of 18. So 0.4536. All right, so those are the first 10 questions. And then we will record 11 through 20 and 21 through mastery for assignments 5.01 number 2 and number 3.